Hey guys, just want to do a real quick recap video of some stuff you learned in Algebra 1, but we're about to get in something called rate of change. And I just want to review this concept before we kind of get into it with slopes, because slopes are basically like a rate of change. So we're just going to do a quick little lesson or review on slopes and how they relate to a linear equation. But let's just take a look real quick at a linear equation. I don't know, let's say I have like y equals 1/2 x minus 3, something like that, right? Y equals mx plus b. So if you wanted to graph that, you go down to the y-intercept, right, which is -3, so 1, 2, 3, right? There you go. And then you just go up 1 over 2, up 1 over 2. So up 1, right 2. So we went up 1, went right 2, you got a little point, you go up 1, right 2, up 1, right 2, and you kind of keep going in that fashion in either direction. You got this right here, right? So the point being is, I just want to kind of reiterate that a linear equation has what you call a constant slope, right? Like no matter where you're at on this line, if you wanted to go further to the right, you could just go up 1, right 2, and you'd be on the line again, right? Up 1, right 2, or you could even go down 1, left 2. Anywhere you're at on the line, doesn't matter. Up 1, right 2, you're still on the line, right? So that's called a rate of change, right? For every 1 you go up, you go over 2, or to the right 2, okay? And it kind of dictates where the line is, okay? So essentially, all you need for a line is just a point and a slope. If you have 1 point and 1 slope, you can have a like a 2D line, right? So point being is lines have just a constant rate of change. We call that our slope. And we're going to get into some things that don't have a constant rate of change and kind of show you how we deal with that later. But we'll be dealing with that later this week, okay? But I just wanted to give you a lesson kind of review on lines. So basically, if you ever had like 2 points, 2 points determine a line, right? So let's say I had a point, I don't know, -1, -1, and something like 5, 8, right? See those 2 points? Okay. Well, if they were on a line, you could find out a slope, right? So say these 2 points are on a line, you could find out a slope, that constant rate of change, okay? And all you have to do is find out like the change in the y over the change in the x, right? That's the slope formula, right? So you could say, you know how this goes? y2 minus y1 over x2 minus x1, okay? That's what we call the slope formula. It's the rate of change for that line, right? So if you did that, you would just say something like, okay, 8 minus -1, right? 8 minus -1 over 5 minus -1, and what you get is you get 9 over 6, right? 9 over 6, which would simplify to 3/2, right? So that means to get from this point to this point on the line, you'd go up 9, right 6, right? Up 9, right 6, or if you broke that into little parts, you go up 3 over 2, up 3 over 2, right? You could do it like that, okay? But now you got what you call a rate of change, right? And if this is indeed a line, that rate of change is the same throughout the entire line, no matter where you're at. If you went right up 3, right 2, you'd be on that line still, okay? So you could use that information if you wanted to and come up with the equation of a line. You could say, okay, well, if I have y equals mx plus b, something like that, right? Well, what do we know the rate of change to be? The slope, it's 3/2, right? So you could just say y equals 3/2 x plus b, like that. If you wanted to, you could just, if you want to find out what that b is, you just plug in like one of these points. I don't know, let's say you put in -1, -1. So if you put a -1 in for y, and -1 in for x, okay, like that, you could solve for that b, okay? So if you just did like -3/2 times -1, that'd be, let me come up here and do this. -1 equals, that's -3/2, right? Plus b, like that. And you just add the 3/2 over here to both sides. B would be -1 plus 3/2, which is essentially 1.5, would just be 1/2, right? So if you did that, you got an equation, essentially y equals 3/2 x plus a half, right? And we just took those 2 points, we found a slope, and by that we found the line as well, right? So y equals 3 halves x plus 1. So my main point today is I just want to show you that a linear equation has a slope, right, which we call rate of change, okay? That rate of change on a line will always be constant, okay? Like I said, we're going to get some things that don't have a constant, what we call slopes or rate of changes, right? And I'm going to show you how to deal with that. But today I just want to take some time and review lines, okay? So a couple things you want to remember about lines. They always have a constant rate of change, a constant slope, right? What else? Oh, okay. 2 points determine a line. So you could go back to your Algebra 1 notes. You could take 2 points and come up with a line. A couple other things you want to remember about slopes too, just to kind of refresh your memories. Parallel slopes are equal, right? So if two slopes have like a 1/2, they both be equal, right? Or perpendicular slopes are what we call negative reciprocals. So if you have this like y equals 3 halves x plus a half right there, and you wanted a perpendicular slope, you remember what perpendicular means? Perpendicular means you cross at 90 angles, right? So if you have a slope of 3 halves and you want a perpendicular line, well, you do the exact opposite, okay? Because 3 halves would be like a positive slope, negative 2/3 would be like a negative slope, and they cross at a right angle. So just a couple things to think about in terms of slope, and that's essentially what we're going to be doing the rest of this week. We're going to be doing slope. We're going to call it rate of change, right? How much the y changes per x, okay? So today's assignment's all just going to be about graphing lines, kind of going back to Algebra 1. Okay, what's the slope here? And using that stuff to find those equations, okay? So just take some time today, dust off the cobwebs from your Algebra 1. We're going to use that information going forward to talk about rate of change, okay? So I will talk to you guys tomorrow, okay? See ya.